Welcome back. It's day 4 of FastFloward. Today we're finally ready to put it all together and ship our first decentralized application, Artist. To do that, we're going to learn about the Flow Client Library, or FCL, how to operate on the Flow Testnet, and how to integrate Flow with a JavaScript/React client. Don't worry, you won't need to know much about JavaScript or React. All the client-side scaffolding is in place, and you'll only have to worry about cadence, FCL, and the Flow Testnet. Day 4 is going to be awesome. Now, a quick review of day 3 before we get going. During day 3, we got to learn about the Flow emulator, which provides a full blockchain experience hosted on your local computer. You can create cryptographic key pairs. You can create and modify accounts by adding those cryptographic keys to those accounts. You can build, sign, and send transactions. You can also execute scripts and get the responses. And finally, you can deploy as many contracts per account as you like. Then we get to learn about the Flow JSON, which is the Flow CLI configuration file. And it uses information to store about your project, specifically your account aliases and your contract names with their associated source files. Once you configured your Flow.json correctly, you'll be able to easily deploy on any Flow network. And lastly, we briefly touched on the cadence event, which allows us to communicate when certain things happen in our contract. Given that transactions don't return results to senders, using emit event in your contract, you'll be able to communicate what happened and return information to your users. Yesterday, we got to see how cryptography plays a part in Flow. When we send transactions, those transactions need to be signed using a private key. As developers, we have no problem with that. Just generate a key pair, store it somewhere safe, and associate that key with a newly created account. We're then able to sign transactions using Flow JSON as our private key store and allowing the Flow CLI to plug everything in. However, if you wanted to enable someone across the internet to use your dApp, you would never ask them for their private key. Imagine you're selling lemonade, a customer walks up, it's $1. However, you only accept payment if you can enter their home with their keys and pick up the dollar bill they have left on their kitchen counter yourself. That's silly. Don't be silly. So if we can't have their private keys, how do we sign our transactions? Well, we send our built transactions to the user's wallet. They take a look at the contents and either confirm or reject the transaction. One last detail, there are many wallet providers, and integrating with them all would be a tedious and fragile process. Flow CLI, the Flow Client Library, we're able to avoid all those difficulties and use it to our benefit. With FCL, you get the entire JavaScript SDK for Flow with an authentication layer on top of it. Meaning, all you have to do to start interacting with a user is call two methods, FCL authenticate and FCL current user subscribe, which passes on the user details once an authentication has been completed. You also get all of the familiar transaction and script functionality in a nice abstracted form, like the following example of sending a script to execute. This is just to give you a small glimpse into FCL. We'll explore it further using our real-world dApp examples. To learn more about FCL from the horse's mouth, have a look at the Inside Flow, the power and simplicity of Flow. It's a recent blog post from the Flow team where they build a strong case for FCL. All this week we were building towards an end goal, a decentralized application that prints our unique drawings as pictures that we own, just like in the real world. But an app is not an app if we can't use it as regular users. Today we're going to explore a client implementation and how it can interact with Flow. And on our screens right now is an example, which you can visit at artist.flowdeveloper.com. And I'm just going to quickly show you how it looks and functions. It's going to sign in. So we're going to confirm, and we're in. So incidentally, I've been drawing some things offline, and I have a number of pictures in my collection. As you can see, I have FLOW. Those are pretty good drawings. We can explore our current balance and the account address along with our collection in the Home tab. We can draw new pictures inside of the Draw tab. Let's see if this one's taken. Very abstract. All right, we click on print, and pretty soon we'll see a pop-up where we can inspect the source code of the transaction, approve it if we're okay with it, and the wallet is going to send it to the Flow Testnet, and as soon as it's sealed and ready to go, we'll get a confirmation, and our interface will update with the result. Sweet. So we have a picture added to our collection. Here we go. So now that it's printed, we won't be able to print it again. Let's just confirm that that also works. We have to go through the same process of submitting a transaction. And once it comes back, we'll see a status update. Alrighty, so as expected, the printer did not allow us to print a duplicate picture. And lastly, we have the ability to click on our profile, and it's a public link. So if anyone were to visit this URL, they would be able to see my collection. So this is the entire app that we'll be implementing today locally on our computers, communicating with the testnet. Alrighty, so now that we know what the app looks like, let's go back to the source code and explore the contents of the folder artist. So I'm just going to navigate myself back to VS Code, and let's go to artist. All right. Inside, you will find the exact same client as on artist.flowdeveloper.com, with the only difference being that the cadence code is missing. This is a JavaScript application. If you're not familiar with either, don't worry. We don't expect you to write any JavaScript if you don't want to. We just want you to be able to run this locally, and a few steps will get you there. So we open up a terminal. We're inside the same folder, and we cd into artist. All right. We do npm I to install all of our dependencies. Next, we'll create an environment file. From our README, there's a neat command we can run. Okay. So this just creates a file and populates it with some URLs. And next up, we can just run the project in a development mode. npm run start will launch our development server, which conveniently enough launches our browser with a tab that opens the correct location. And we have our local artist instance running locally. If everything went well, you should be able to click on authenticate and click on draw, trade, and home. Now everything is stubbed out, so this is not connected to the blockchain, but you still should be able to interact with the user interface parts. For the time being, that's all we need in terms of deployment, and we can go and take a look at the structure. There are two important locations inside of the artist folder that we are in right now. The first one is the cadence, the new cadence contract that's called local artist. And the second one lives inside of context, and that's flow.jsx. The artist client app uses flow.jsx as a single point of contact with the Flow blockchain. Inside, you'll find a React context, and it's made available throughout the pages of the app. The main part is that in this file, we create functions that wrap around our transactions for later use, and we pass them along to whomever is interested. Right now, those functions, such as log in and log out are stubbed out. Our goal today will be to implement them by executing scripts and transactions that exist inside of our source/cadence folder with the help of FCL. Some implementations will be one-liners. For example, log in and log out. Those should be one-liners. And some will require a little more effort. Hopefully, we now have a basic understanding of the project structure as far as today is concerned. Our next step will be to configure Flow for testnet usage. Let's go. Day 3 was all about the emulator and interacting with the local instance of the Flow network. Today, we want to go public. We'll do that by deploying our local artist contract to the Flow testnet. The process is exactly the same as the process to deploy emulator contracts. The only difference, we don't have direct access to the testnet service account, and we can't create an account without already having an account. But Flow has got us covered. We can create and fund an account on Testnet using Flow Faucet. It's a free service provided by Flow. All that's needed is a public key that we can generate using Flow CLI. So let's go ahead and visit that site. Here we go. And we need the public key like I mentioned. Let's create a new tab and let's run the Flow keys generate. All right, so we grab the public key, paste it in, select the appropriate algorithm, make sure that we're still human, and we click create account. All right, let's grab the address and initialize our configuration. Let's make sure that we're in the right spot for it. That will be source cadence. Okay, so now we can go ahead and run flow init. Perfect. Then let's update our flow init with the appropriate data. Let's call this testnet local artist. The address is going to be the one that we just got from the Flow faucet. And the key, I'm going to type out. Okay, we have our testnet local artist account configured. Now let's add our contract. We're going to call this local artist, and it's located at local artist /contract.cdc. Okay, and finally, we add a deployment for testnet, and we're using the local artist account, and the only contract that we'll be hosting there, deploying there, is the local artist. Cool, so this is looking good. One thing that we need to add as well is inside of our env file, we need to expose the account address that's hosting the contract. So we'll go ahead and do that. It's right here. Also, let's provide the name for the contract, which is local artist. Sweet, so that completes the setup sequence. You might have noticed that we're using local artist as a different name for our contract. Since a storage path must be unique, we want to avoid naming conflicts with artist.flowdeveloper.com contract storage. So we're just using a different name. Another change is that we're no longer using a space and a star to indicate on and off pixels. From now on, we'll be using 1 for an on pixel and 0 for an off pixel. You might find other changes in the contract code if you're curious. Right, on to deploying the local artist contract to testnet. Flow project deploy network testnet. All right, we just wait until the contract is deployed. Alrighty, we have our project deployed. Another useful tool for working with the testnet is the Flow view source. It's linked inside of the README file. We can take a look at that right now. This specific link is for one of my testnet accounts. We can also take a look at the one that we just deployed our contract. Let's see here. Okay. All right. So we see that our contract is deployed and we can view its source. Now let's test our deployment using Flow CLI before we move on to FCL. Before executing the first transaction, please make sure that you update the source code for print, and we need to change this value to the account address that we just deployed this contract to. Okay, put that in place. Let's go ahead and copy the transaction command and let's execute it. If successful, as is the case right now, we should see 5 events from the execution. Specifically, we're interested in picture print success and picture deposit. If we run this again, we should see that the printer blocks printing a duplicate picture, and we'll get a different set of events. All right, we see that picture print failure event, which lets us know that the printer is working fine. One last thing to complete our testing, we have this script right here, and we want to see what the collection looks like. Again, let's make sure that we provide the correct address, and in that case, it's an argument. Let's just update the argument. Run this, and we get a collection with 1 picture inside of it. Now that we have confirmed our contract deployment, we can proceed to integrating FCL. First, we need to configure our network and wallet that we want FCL to use. This is done in the index.js file. As we can see, we're calling, first of all, we're importing FCL, and we're configuring it with 2 values, one for the access node, which is the Testnet access node, and then the wallet service, which is the Testnet wallet service. We do this once at the entry point to our client. Since we're operating on the Testnet, we're using the Testnet access node and the Testnet wallet. In order to manage user authentication, we use 2 functions, the FCL login and FCL unauthenticate functions. We just need to place them in the right spot within flow.jsx. And I wonder what those spots would be. Okay. FCL provides a single interface for sending both scripts and transactions. For example, a transaction would look something like this. We have our FCL.send method that takes in an array of other objects, FCL objects. For a transaction, that would be the .transaction object that takes in a template string. It's simple, just import your contract from and so forth. So just your regular Cadence code goes here. And then you provide, if need be, a list of arguments using the fcl.arg function. And this looks a lot like what you would use inside of your command line. You provide a value and then you provide the type that that value is in. For transaction, it goes a little further where we define a payer, a proposer, and an authorization. For all of our transactions, we only have 1 user involved. So we just use fcl.authz, which is a shorthand for the currently logged in user. And then we set the gas limit. In this case, we're using the max because we don't really want to get bogged down with how much gas would this transaction cost. And then finally, we decode the response into a JavaScript object response. So it parses out Cadence into an equivalent JSON map for JavaScript. The last part is we wait until the transaction is sealed to return the response. And executing a script, it's very similar, but it does not require any authorization. So we build another array for our send method, and that includes a script object that takes in a template string. That's also just Cadence source code. If you need to include variables from JavaScript, you can use the $ and curly braces and do 1 + 1, and this will be 2, where you can reference other things like account address or something. If you want to reference a specific element inside of your environment, you just do process.env the name that's in the file. All right. So that is sending transactions and scripts. This should be enough to get started. For more, obviously, please refer to the Flow client library documentation, and you'll find the link on GitHub. Alrighty, we're finally building real decentralized applications, and that's epic. To celebrate, we only have one single quest today. Well, a single quest with 7 parts. The name for the quest is Client is King. So the point is you search for to-do items inside of this project, like so. And you'll find a list inside of flow.jsx of all the to-do items. Next, you look at each to-do item and you implement that task using an FCL method, either sending a transaction or executing a script. After you've implemented all of the to-do items for this quest, you'll have an equivalent functioning app just like artist.flowdeveloper.com, sending, printing pictures, storing them with your collection. As part of your submission, please fill out the quest.md file, which is right here. And we expect you to provide us with your contract account address for Testnet, and then your Blockdo account address for Testnet. You'll be able to find the Blockdo address once you authenticate yourself. They'll be in the bottom left corner right here. All right, that should be it. Best of luck on your quest, and I'll see you during office hours.